Welcome to Educator.com. In today's lesson, we're going to continue our discussion of rational expressions, today focusing on dividing rational expressions. The procedure to divide one rational expression by another is to multiply the first rational expression by the reciprocal of the second. So once you've found the reciprocal of the second expression, then you follow the rules of multiplication, because that's what you're doing, is multiplying at that point. All right, let's go ahead and talk about how you approach dividing fractions that are just regular fractions, they're not rational expressions, with numbers, because it really is the same idea. So if you have 5 over 12, which is a fraction, and you're going to divide that by 12 over 9, what you're going to do is find the reciprocal of 12 over 9. So the reciprocal means that you're going to reverse the numerator and the denominator. You're going to switch those two. Therefore, instead of 5 over 12 divided by 12 over 9, you're going to write this as 5 over 12 times the reciprocal of 12 over 9, which is 9 over 12. So at this point, you're just multiplying, just as you always would. And as part of multiplication, remember that you're going to first simplify. So I have a common factor of 3. So 3 goes into 9 3 times and into 12 4 times, and that's going to give me 15 over 48. Okay, doing the same, you're going to really be doing the same thing with rational expressions. For example, if you have 2x over 3y divided by 4x squared over 9y cubed, find the reciprocal. So I'm going to keep this first expression the same, and then I'm going to multiply by the reciprocal of the second expression. So now the denominator is going to become the numerator, and the numerator is going to go down and become the denominator. Then I start canceling out common factors. So here I have a common factor of 3. These two numbers have a common factor of 2. For x, I have a common factor of x, so x squared becomes x. The y's have a common factor of y, this becomes y squared. Now I multiply. And this is, I'm left in the top with just 3y squared, and the bottom is 2x. So in order to divide, you really have to know how to multiply. So make sure that you have your multiplication of rational expressions down, because other than that first step, the rest of the steps involve multiplication. After you do that important first step of changing the second expression to the reciprocal and then multiplying instead of dividing. After inverting the second rational expression, cancel common factors in the numerator and the denominator before you multiply. So cancel before multiplying is a technique that we discussed in the earlier lesson on multiplying rational expressions. And recall that the reason we cancel before multiplying is by doing that, you're going to get a simpler expression. Multiplication is going to be much faster and easier. If you wait and multiply first, you're going to be multiplying larger numbers, more complex expressions, and it's going to be a lot more work. So the first step is invert, change to multiplication, invert the second rational expression or find the reciprocal, cancel common factors in the numerator and denominator, and then multiply. An example, if you had something like x cubed, y squared, z cubed over 8x squared z, and you were asked to divide that by x squared y over 6x y squared z squared, the first thing that you're going to need to do is invert this. So I'm rewriting this first expression, it's just the same. Now I'm changing it to multiplication, but I'm going to invert or find the reciprocal of this second expression. And that's going to give me, this is going to become the numerator, 6x y squared z squared divided by x squared y. Now I'm just going to go ahead and start finding my common factors and canceling those out, and then I'll multiply. 6 and 8 have a common factor of 2. So 2 goes into 6 3 times and into 8 4 times. I see I have a common factor here. I've got x cubed up here, x squared below. That cancels. That becomes just x. I've still got some x's left, so I have an x up here, and I have an x squared down here. That becomes x, leaving me with these x's. They cancel. Okay, for y's, I have a y squared here and a y here. Cancel the y, make that y. Z's, z squared in the numerator, z in the denominator. The z canceled, this just becomes z. Let's see what we have left, and then multiply. So I have y times 3 times y squared. In the denominator, I just have a 4. I do my multiplication to pull my 3 out in front. That's going to be 3. Y times y squared is y cubed divided by 4. So rewriting this here, just clear. This is going to be what I'm going to end up with. Remember, invert that second expression, then you end up with multiplication, cancel common factors, and then multiply. Now, when you're working with rational expressions containing polynomials, after inverting the second rational expression, factor the polynomials in the rational expressions, then cancel the common factors and multiply. Again, what we're doing is doing some simplification before multiplying to make it easier. For example, if you have an x squared minus 6x plus 9 rational expression, so it's divided by x plus 5, divided by x squared minus 9 divided by 2. First step, invert the second rational expression. So this first expression remains unchanged. Multiply by the reciprocal of the second expression, which is 2 over x squared minus 9. Now, factor the polynomials in the rational expressions. Okay, first one, numerator. I have x, and I have a positive here, but I have a negative here. And what that tells me is that I've got 2 negatives. So I've got x minus something times x minus something. And factors of 9 are 1 and 9, but that is not going to add up to 6, and 3 and 3. Negative 3 and negative 3, those are going to add up to 6. So I've correctly factored this. X plus 5 is already as simple as it can be. Here I have the difference of 2 squares. So I'm going to rewrite that in its factored form, x plus 3, x minus 3. So I inverted the second expression, did my factoring. Now I'm going to cancel common factors. Common factors here are x minus 3. It's the only common factor that I see. No other common factors. So now it's time to multiply. And what I have left is x minus 3 times 2, putting the 2 out in front. And in the denominator, I have x plus 5, x plus 3. And I leave that as it is in factored form. Okay, applying these concepts about division with rational expressions to some examples. Divide. First, find the reciprocal of the second expression. Okay, find the reciprocal of the second expression, then cancel out common factors, then multiply. Okay, Rewriting this first expression just as it already is, 6x squared y cubed z to the fourth divided by 15x y to the fourth z squared times the reciprocal of this. Numerator becomes the denominator, denominator becomes the numerator. Bringing that down to the denominator gives me 8x squared y w squared. And just double checking to make sure everything's copied correctly when you're working with this many variables with exponents. Okay. Next step, cancel out common factors. So I see here I have a common factor of 3. So this becomes a 2. 3 goes into 15 5 times. 5 is a common factor with 5 and 25. That cancels. This becomes 5. And I've got a 2, which is a common factor with 8. That cancels. This becomes 4. So I'm done with my numbers. And now I want to work with my first variable, which is x. So I have x squared here and x squared here. I still have some x's left in the numerator and denominator. So I have an x cubed here and an x in the denominator. This x cancels out to give me x squared. Working with the y's. I have y cubed here, y to the fourth here. This cancels, and it's going to leave me just with y. I've got a y squared here. Can cancel this y, make this just a y. I still have a y in the denominator. Those cancel. Okay, I'm getting there. So I have z to the fourth and z squared. This becomes z squared. This cancels out. I have no more z's in the denominator, so I'm going to go to w. I have a w here and a w squared in the denominator. This w cancels out. W squared becomes w. Let's see what I have left. In the numerator, I have a z squared. I have a 5. I'm going to pull that out in front. And I have a z squared. In the denominator, I have 4. Nothing over here. I have a 4 and I have a w. Multiply. So I found the reciprocal. I canceled out common factors, and now I'm multiplying. And this is going to give me 5z to the fourth over 4w. So in order to divide, I had to find the reciprocal, cancel out, and then multiply to give me my final answer, which is 5z to the fourth over 4w. Second example involves polynomials, and my first step is always to find the reciprocal of that second term. So I'm going to go ahead and do that before I do anything else. So now I'm multiplying by the reciprocal of this. I'm going to take the denominator, 24z plus 72, and put it in the numerator, divided by 9z plus 45, which is going to go into the denominator. Next, I'm going to start factoring. So after I find the reciprocal, when I'm working with polynomials, I have to factor before I can cancel out. Can't cancel until you factored. Okay, in this numerator, I have 3 as a common factor. This is going to become z minus 6. In the denominator, 8 factors out to give me z plus 3 left behind. Here, I have a common factor of 24, leaving behind z plus 3. In the denominator, 9 is a common factor, leaving behind z plus 5. Okay, so I've factored everything out, and I'm looking for common factors. And I have a common factor of z plus 3. That's going to cancel. As far as the numbers, I have a common factor of 8, and it goes into 24 3 times. That gives me 3 and 9, which have a common factor, and 3 and 3. Those cancel out. So all the numbers canceled out, and that leaves me with, in the numerator, z minus 6, in the denominator, z plus 5. Again, to divide rational expressions, you multiply by the inverse of the second fraction. When you're dealing with polynomials, you need to factor. Factor those out as completely as you can. Start canceling out common terms. Cancel out as much as you can, and then multiply whatever's left. In this third example, we again have polynomials. Rewriting this first expression times the reciprocal of the second expression. So the denominator is going to become the numerator. 2y squared minus 14y plus 24 divided by, this numerator is going to the denominator, so flipping those two around. 2y squared plus 11y plus 15. Next step, after I've found this reciprocal, is to factor. For this numerator, I have a common factor of 3. So this becomes 3 times 2y plus 5. And then at the bottom, I have 4y minus 16. So I'm going to factor out 4. And that's going to give me y minus 4. In this trinomial, I do have a common factor of 2, leaving behind y squared minus 7y plus 12. In the denominator, I do not have a common factor, so I'm going to leave that as it is. Okay, this first expression is already factored out, so I'm going to rewrite that just as I had it. The numerator needs to be factored here, as does the denominator. And what I have is a positive here and a negative here. And that tells me that I'm multiplying two negative numbers. So, factors of 12. I need factors of 12, and then I need them, they're both going to end up being negative. And when I multiply them together, of course, they're going to equal 12. But when I add them together, they also need to add up to negative 7. That's going to be my criteria. Well, I can see that adding 1 and 12, or negative 1 and negative 12, is going to give me negative 13, so that's not correct. If I add 2 and 6, negative 2 and negative 6, I'm going to get negative 8. If I add negative 4 and negative 3, they do add up to negative 7. So these are the correct factors. This factors out to y minus 4, y minus 3. Second one, I have a leading coefficient of 2, and that's going to give me 2y here and a y here, and everything is positive, so these are both positives. So I need factors of 15, (1 and 15), and 3 and 5. And I need factors that are going to add up to 11y when I have this 2y thrown in the mix, which makes things more complicated. And 15 is large. These are too far apart. I'm going to go for these two factors. So I'm going to try 2y plus 3 times y plus 5. So I'm going to try that first combination and see how it works. I'm going to try these first. 2y times y, so that's 2y squared. Now let's try the outer and inner terms so I can figure out if my middle term comes out to 11y. 2y times 5 gives me 5y. 3 times y is 3y. So that gives me 8y. That does not equal 11y. So that's not correct. Let's try it the other way. Let's try 2y plus 5. y plus 3. Outer terms, 6y. Inner term, 5y equals 11y, which is what I want. My middle term is 11y. So I know that this has been factored correctly. So I'm going to factor as 2y plus 5. And seeing that this is 2y plus 5 here, that might have been the one to actually start with. That it would have been a good guess because things would come out very neat and nice if that was the factor, because these will cancel out. So that's another way you can look at it if you're given a problem is, okay, what would help me out? Well, if this was 2y plus 5, so you could even try that combination first and then know that the other factor has to be 3. Okay, so I've factored this out. I need to cancel out common factors. Let's see, 2y plus 5 is a common factor. And do we have any other common factors? We do. We have a 2. So 2 goes into 4 2 times. And another common factor is y minus 4. All right. Those are all the common factors. So now I multiply. I have a 3 times y minus 3. In the denominator, I have 2, and I have y plus 3. And this is my answer. So in order to divide, I had to invert this second expression, do quite a bit of factoring, got it down to this point, and then I simply had to cancel all these common factors and multiply. That concludes today's lesson from Educator.com. I'll see you soon.